Welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we are listing subsets of sets. So let's start by reminding ourselves of the various symbols we need to be familiar with. So, can you remember what each of these mean? The first one means is a proper subset of. Okay, so you might say A is a subset of B, or a proper subset of B, if A, this set here, is entirely contained within B. So if that was A and that was B, that would be a scenario where that's true. The next one just means is a subset of. And when you have that symbol, it can be a strict subset of, but it can also equal the set. So that is slightly different. The next one means is not a proper subset of. And the last one is the empty set. Remember a rule we talked about previously. The empty set is a subset of any set. Okay, it's always a subset of any set you've got at all, so any one you can think of. So that's a rule. So in this video what we're going to do is we're going to be given a set and we're going to be asked to list all the subsets of that set, either the proper subsets or just or the actual subsets including the set itself. So let's start off with a question. If you feel like you can do this, pause the video and go ahead. Right, we're asked here to list all the subsets of A. A is the set with elements 1, 2 and 3. Now, the first thing to do is they're not proper subsets, so you always know that the empty set is a subset, and secondly, you know the set itself, the set A, is a subset of A. That is a rule. Okay? Now, the next thing you need to do is you need to list the subsets that have one element in them. So they would be the sets 1, like that. You must put the brackets around them to show their sets, 2 and 3. And what other type of subsets could you have? Well, you could have the subsets that have 2 of the elements out of A in them. So the way I like to do these is I say, well, either they've got 1 in them or not. So if it had 1, it would either be 1 and 2, or it would be 1 and 3. And if it didn't have 1 in it, it must be the set that has 2 and 3 in it. So they are all the subsets of this: the empty set, the set A itself, the sets with elements 1, 2 and 3, and the sets with elements 1 and 2, 1 and 3 and 2 and 3. Now if someone asks you to list all the proper subsets, well, they're very like above, except we wouldn't have this one in it. So if I was to list them out, we would have the empty set, we would have the sets with 1 element in them, 1 element like this, and we would have the proper subsets with 2 elements in them like this. And we're done. Okay, the next one. Pause the video and have a go at this. So we're asked to list all the subsets of B. Now B has 4 elements in it: A, B, C and D. They're not the proper subsets, remember, they're all the subsets. So let's start off nice and easily by saying, well, the first one is the empty set. Easy. Right? The next one is the set itself, B, which we can state. B is a subset of B. Now the next one are going to be the sets with 1 element in them. So they're quite easy to reel off. They're the sets A, or the set B, or the set with C in it, or the set with D in it. Now the next one are going to be the sets that have 2 elements in them. Okay, so let's assume we've got A first of all. Let's just assume A is in one of them. Now if A is in one, it could either be with B, A could either be with C, or A could be with D. Right, now let's assume A is not one of them. So let's assume that the first element is B, but A is not in them because we've already taken into account this. So B could be with C, or B could be with D. And lastly, we've considered the cases where A is in them and B is in them. Let's now consider the case where A and B can't be in them, so C has to be paired up with D in that case there. And the fifth scenario is the case where we've got 3 of these elements. So again, let's imagine A is definitely one of those 3 elements. So if A is in it, then either B and C must be in it. That's one scenario. Okay, the other scenario, if A is in it, it could be the case that B and D are in it. So I'm going to write that as a scenario. Okay, and the other scenario is if A is in it, then C and D could be with it, like that. Now that's the scenario when A is certainly in it. Let's now consider the scenario where A is not in it. And where A is not in it, then the only combination is to have B, C and D. Like that. And there you go. They are all the subsets of the set B. Okay, the last one. Pause the video, have a go. Okay, here we're asked to list all the proper subsets of A intersect B and or A intersection B and A union B. So let's start off by listing the elements in each of these sets. The universal set here, they're the integers between 0 and 6, including 0 and 6. So they're as follows. Now A are the list of numbers that are multiples of 3 and in the universal set. So they must be 3 and 6. And B is are the numbers that are factors of 15 and in the universal set. So they must be 1, 3 and 5. Like that. Now it says list all the proper subsets of A intersect B. Now let's just start off by saying what A intersect B is. A intersection B, they are the elements in A and B together. There is only one element in A and B, and that is the element 3. So we know that this is the set with 3 in it. Now if someone said what are the proper subsets of that, the only proper subset of that is the empty set, because you can't have 3 is not a proper subset of that. 3 is equal to that set, so the only proper subset of that is the empty set. What about A union B? What is that list? Well, they are that is the elements that have 1, 3, 5 or 6 in them. 1, 3, 5 or 6. So listing the proper subsets of that, there are various scenarios. Remember, you have the empty set is one scenario. You don't have the total set here because that is not a proper subset, but you have the sets with one element in them, so they would be as follows. Then you would have the list of sets that have two elements in them. So let's assume you've got the element 1 in them for now. Let's just think of all those scenarios. You could have 1 and 3. You could have 1 and 5. You could have 1 and 6. Now let's assume you can't have 1 in it, but say let's force you to have 3 in them. So let's say the next one you could have 3 and 5, or you could have 3 and 6. And let's assume now it can't have 1 or a 3 in them, it has a 5 in it, so the next one must be 5 and 6 is the only option. Okay, then of course you have all the sets that have 3 elements in them. Okay, so let's again assume you've got 1 in it. Let's think of all the scenarios that have the element 1. So you could have 1, 3 and 5. You could have 1, 3 and 6. You could have 1, 5 and 6. Now let's assume you don't have 1 in them. Therefore, if you have 3 in it and you can't have 1, the only option you've got is to have 3, 5 and 6. And they are all the proper subsets of A union B. And that's it for this particular video. Thanks for watching.